Ready-made maths, YouTube mathematics training. Teacher and teaching assistant training in mental multiplication. We're now up to day 7 of the range of strategies we've been looking at. And this is my favourite one, manipulate the calculation. So let's do a little bit of manipulating mental calculation. If I'd have asked you 2 or 3 weeks ago to work out 35 times 14, what's the usual strategy that people go for? Well, usually people would start with 35 times 10 equals 350. And we could visualize that with base 10 apparatus and prove 35 repeated 10 times, you end up with 350. 35 times 4, again, we could prove that with 4 35s or by partitioning. So 30 times 4 is 120, 5 times 4 is 20, add them together, 140. The other alternative is just a double and double. Double 35 is 70, double 70 is 140, the strategies that we looked at yesterday. Whichever way you do it, your overall product is 350 and 140, which equals 490. But can it be done much quicker? Well, one way we've looked at previously is factorizing, which is one way that would definitely make it slightly quicker. But today, we're going to go one stage further. We're going to try doubling and halving, or as it's now known, manipulate the calculation. So let's head off to the ready-made classroom and see how that works.
Hello and welcome back to the Ready-Made Mathematics YouTube training videos. What we're doing today is looking at one of the final couple of mental arithmetic strategies for mental multiplication. This one is manipulate the calculation. You may remember this one from when we looked at addition, and we had calculations for addition. Just give you a really simple one such as 8 plus 7. We manipulated the calculation by making another calculation that's slightly easier. What we kind of did was we passed 2 over from the 7 to the 8, and we made 10 plus 5. We then started to use that with bigger numbers, so if we had a calculation such as, 298 plus 356, we made that calculation much easier, again by passing 2 over. We just kept the same amount in total, but we passed 2 over, and that became 300 plus 354. So again, 10 plus 5 is a much easier calculation than 8 plus 7. 354 add 300 is definitely a much easier calculation than 356 add 298. And so we looked at that as one of the main strategies for addition. We're now going to look at a similar strategy, but how it applies for multiplication. So can we change the calculation to make the actual strategy much easier? Now the 3 calculations you can see here are similar to ones that we did earlier in the week for factorising. And actually you'll end up with a similar principle for how to find the answer. But what we're going to do today is, rather than factorise, we're just going to change the calculation. We're going to create an easier one that will get the same answer. I'm going to come back to these 3 shortly, but in order to show the method in a little bit more detail, we're going to go back to the table, and we're going to actually make a simpler calculation, and we're going to build it up and see what happens. So the calculation we're going to look at is a much easier one. We're going to start with the calculation 3 multiplied by 8, and we're going to see what else we can work out from that. What we're going to do then is we're going to have a little play with the calculation 3 times 8 equals 24. 3 multiplied by 8 gives a product of 24. What else can we work out? Well, yesterday we did the doubling strategies, and we worked out that 3 times 8 by doubling one of the numbers could give us 6 times 8, or it could give us 3 times 16. So we've practiced that one yesterday. What we're going to do today is look at something slightly different. Can we keep the product the same by moving around the calculation? So we're going to keep an answer of 24 but change the calculation. So that's what we're going to start with, 3 times 8. Let's look at the table. And I've actually created 3 multiplied by 8. As I mentioned before, some people would call this 8 times 3. They'd call it 8 lots of 3. I would call this 3 multiplied by 8. You'll still end up with the same picture. So I've taken my 3 times 1, 2, 3, 4, 5, 6, 7, 8. 3 multiplied by 8. Let's just quickly check it's 24. 3, 6, 9, 12, 15, 18, 21, 24. So at the moment I've got 8 3s. I've got 3 repeated 8 times. All I'm going to do now is quite simply double up the numbers like this. So I'm going to basically put the towers on top of each other. Just pick that one up again. Put that one up there and put that one on there. Right, now we can see we've still got 3 multiplied by 8, but what have we now got? We've doubled the size of the towers. How many have we got in each tower? Well, we've now got 6 in each tower. So we've now got 6 multiplied by 4. So we started with 3 multiplied by 8. We've now doubled the amount in each tower, but we've halved the number of groups. We've ended up with the same total because we've got the same amount. We've still got 24, but we've now got 6 times 4 equals 24. So I'm just going to record that and we'll see what happened. 6 times 4 equals 24. Let's have a quick look now. We started with 3 8 times. We've now got 6 4 times. The product has obviously remained the same. What's happened is the number in each group has doubled from 3 to 6. The number of groups has halved from 8 to 4. Therefore, the product stays the same. Let's try the same thing again. So what I'm going to do now is put that one on top of there. Hope it stays up. And put this one on top of here. Again, luckily, we can still see all the 3s. So we can still see we've got 3 8 times. But let's look at how many there are in each of the towers. Well, in this tower, we've now got 3, 6, 9, 12. So again, we've doubled from 3 per tower into 6 per tower, and we've now got 12 in each tower. How many towers have we got? 2. So we've now got 12 multiplied by 2, or double 12. So you can see what's happened now. We've still got 24. We've still got what we started with, but we've now put them into bigger towers. Let me write that one down. Times 2. And there we go. What we've now got is 12 multiplied by 2. So again, the number in each tower has doubled, but the number of towers has halved. The product has remained the same. Obviously, last but not least, this will look a bit silly, but we're now going to create, ooh, hope this works. There we go. We've now got one extremely large tower. How many is there in the tower? Well, we know the answer must be 24, because that's what we started off with. 3, 6, 9, 12, 15, 18, 21, 24. What's absolutely lovely, we can still see the 8 3s, the 3 multiplied by 8, but we've now got one tower with 24 in it. So what we've now got, how many in the tower? 24 multiplied by 1. And that's basically the principle of manipulate the calculation. All we've done is we've doubled one number, halved the other, the product stays the same. Doubled one number, halved the other, the product stays the same. So they're all 24. They just we basically manipulated the calculation so that you can see it in different ways. What we're going to do now is we're going to go back to the board and let's see if we can apply that strategy in the abstract with bigger numbers.
And as we just saw in the Reddy Maths classroom, we can now see an example of using cubes or counters to prove the doubling and halving theory. We can see here 3 multiplied by 8. And what we're then going to do is we immediately half the 3 multiplied by 8. We take the red, the blue, the yellow, and the purple, and put those underneath. And what we've now got is 6 multiplied by 4. So we've basically gone from 3 times 8 to 6 times 4. 3 multiplied by 8 to 6 multiplied by 4. We have one side and we doubled the other. Simple. What we then do is we do exactly the same thing. We have that, and we're now going to move the red and yellow line and the grey and purple line and put them under the others. So 6 multiplied by 4 becomes 12 multiplied by 2. Again, 6 multiplied by 4 becomes 12 multiplied by 2. We could obviously then create another line of 24 multiplied by 1. But we can still see we've got 1, 2, 3, 4, 5, 6, 7, 8. We've still got 3 multiplied by 8, but it's now in 2 lines of 12, or 12 multiplied by 2. And as we're going to see now, that theory can be applied to any set of numbers. And just very quickly, proving that theory and using just abstract numbers this time rather than a picture, if we were asked to find all the factors of 60, well, we could start off with the first one, 60 multiplied by 1, or 1 times 60, whichever way around, or 20 multiplied by 3. By doubling and halving, we can very quickly get 30 times 2 and 10 times 6. And by doubling and halving again, we end up with 15 multiplied by 4 and 5 times 12. So very quickly we found all the factors of 60 just by using the doubling and halving principle. So let us go back to the number we started off with. We began with 35 multiplied by 14. That was the calculation we kicked off with at the start. Yes, we can partition it. Yes, we can factorize it. But the quickest way, there's 35, there's 14, double 35, 70, halve the 14, 7. When you double one number and halve the other number, the product stays the same. 70 multiplied by 7 gives us a product of 490. So we've looked at it kind of visually. Let's now look at the same principle, but this time in a kind of mathematical rule. Key rules of multiplication. Well, if we start with a multiplication fact, any multiplication fact, and double one of the numbers, let's start with, for example, 6 times 4 equals 24, then the product doubles. So what you can see here, there's 6 multiplied by 4, 6 times 1 times 2 times 3 times 4. If we double either of the numbers, we can double it to 12 multiplied by 4, and obviously the product will double to 48, or we can double it to 6 multiplied by 8, and the product again will double to 48. So double one number and the product doubles. We looked at that in the previous video. Alternatively, we haven't looked at this one yet, but the principle still applies. We start with the same fact, 6 multiplied by 4. If we have either the 6 or the 4, and the product halves, you can see that straight away because you can see half of the amount we started off with. Here's the 24, which is 6 4 times. We have the 6, we now get 3 4 times, or 3 times 4. Or alternatively, we have the 4, and rather than getting 6 times 4, we get 6 times 2. So again, the same principle applies. If you have one of the numbers, the product halves. And so, kind of combining both the rules, if we start with a multiplication fact, we double one of the numbers and halve the other number. Let's back to the same one. 6 times 4, we can double the 6, and we can halve the 4. Or we can halve the 6 and double the 4. Let's have a look. So we can make it 3 multiplied by 8, halve the 6, double the 4. Or we can make it 12 multiplied by 2, double the 6 and half the 4. As you can see, because we've kind of made it equivalent, whatever we've done to one side, we've done the opposite to the other, we end up with an answer of 24. The product stays the same.
What I want you to do now is look at these calculations here and think to yourself, well, if we use the idea of doubling one and halving the other, mathematically we've just proven the product always stays the same, so we don't have to start with 45 times 14, 25 times 16, or 35 times 18. Let's double one number, half the other, and let's see what happens. So let's just pause the video. As I said, I love this strategy now because look what we can see. We had 45 times 14. All we do, we double the 45, we have the 14, exactly like we did on the table. We end up with 90 times 7. 7 9s are 63. So 90 multiplied by 7, 630. We've changed it from something difficult to something easy just by manipulating the calculation. Exactly the same. 25 times 16 doubles up to 50 and halves to 8. 50 times 8, 400. And this one, 35 times 18, again, we double the 35 to get 70. We halve the 18 to get 9. And again, as with the first one, we end up with a product of 630. How easy is that compared to a long multiplication or any other strategy? I'm going to pause the video now. I'm going to write 3 more calculations on the board for you to have a quick go at. Then we're going to have a look at the PowerPoint and look at how this strategy can be extended with other types of numbers as well. Just looking at a decimal example as well before you have a go at these 4. What about if we have 1.5 times 24? That looks horrible. A lot of children would look at that and go, oh, don't like that one at all. Again, you could do 24 ones and 24 halves if you want to do it that way. What we can definitely do, we know the product's going to be the same. We double the 1.5, we get 3. We halve the 24 and we get 12. Look at that. They've got to be the same. We've manipulated the calculation, so 1.5 times 24 must be 36. That's going to really help a lot of children who are doing multiplying by relatively simple decimals. Can you now have a look at 3.5 multiplied by 18? Another decimal one, 2.25 multiplied by 28, that looks horrible. And 2 long multiplication calculations, 24 times 250 and 125 multiplied by 36. You may have to double and halve more than once, but have a look, can you work out a much easier way of manipulating those calculations? So starting with 3.5 times 18, double the 3.5, 7, halve the 18. Look at the difference between those calculations. 7 times 9, 63, done. Again, it doesn't matter which way around we do it. This time I've halved the 24 first and double the 250. That gives me 12 multiplied by 500. I can work that out from where it is, but actually let's go a stage further and make it 6 times 1,000, which would obviously give me 6,000. Similarly here, I've doubled the 125 to get 250, and I've halved the 36. I'm still not very happy with 250 times 18. I'm far happier with 500 multiplied by 9. So I've just done that twice, and that gives me 4,500. And last but not least, this one again, you might need to think of this as 2 1/4, but 2 1/4 doubled is 4.5, or 4.5. Half of 28 is 14. Still not very keen on it, so let's just do it again. Double 4.5 is 9. Half of 14 is 7, and guess what? We're back to 9 multiplied by 7 equals 63. Again, I think the fact that we can do all of these so quickly, if we spot and recognise that idea of manipulate the calculation to make one that's considerably easier.
So I hope you found all those examples in the ready-made classroom really useful. Just some revision of some of the ones that we've just been looking at before. Just to start off with, just to prove that 45 times 14, as we've seen previously, can be done by factorising 45, and we factorise the 14 into 2 and 7. But actually, which does give you 90 times 7, doing it the other way, just doubling and halving, saves you a stage. Just makes the same principle, but a little bit quicker. Double one, halve the other, we still end up with the same calculation at 90 times 7. So we did look at factorising the other day, and that works really well for many calculations, but for this particular one, the doubling and halving seems to be a better strategy. Now, let's have a look at one of the calculations that we saw in the classroom. 16 times 3, as we saw, halve one number, double the other number, we end up with 8, multiplied by 6. 8 times 6 is 48. But actually, in a similar way to multiplying something by 10 and dividing something by 10, or multiplying something by 2 and dividing something by 2, actually, you can do anything with multiplication as long as you do the same, so you do the opposite to both of the numbers. 27 divided by 3, 3 times 3. 27 divided by 3 is 9, 3 times 3 is 9. The equivalent calculation, we've manipulated it to make it much easier. 9 times 9 equals 81. And that's where this strategy does get really interesting. We can divide or multiply by any different number, and we will end up with the same product. Let's look at a couple more examples. So we've seen 45 times 14 already, but what about that one? 36 multiplied by 25. Again, we can double and half twice. We can half 36 to get 18 and half again to get 9, but why not just divide by 4? 36 divided by 4 is 9. 25 multiplied by 4 is 100. Straightforward. 9 times 100 is 900. And then I'm going to pause the video now and just give you a chance to have a quick look at the 3 examples that we've given here. Now, we did see some of these examples back in the classroom, but with those, we doubled and halved twice. What I want you to look at are these 2 and just see how easier it is if you just divide and multiply by 4, and similar over here. And then take a look at this example. So with 26 times 32, we've got the option of double and double, or just times by 4. 4 20s are 80, 4 6s are 24, add them together, 104. 32 divided by 4 gives us 8. We've manipulated it, so rather than having a horrible long multiplication, we've just got a much simpler 104 times 8. Straightforward. With this one, the same idea, let's just double this one twice. 52, 104, 208. Divide this one by 4. 24 divided by 4 is 6, or half it twice. 12, 6. What would you rather have? 52 times 24 or 208 times 6? I know what I'd rather have. 200 times 6, 1200, 1200. 8 times 6, 48. Look at the difference between those calculations. Finally, an example here that's quite an interesting one, 32 times 15. Now, we could partition times by 10 and times by 5, or 32 times 5 is 160. 15 divided by 5 is 3, and we end up with 160 multiplied by 3. Again, just an alternative way that you might find more interesting. So that brings us into all of the strategies that we've been looking at over the past 7 or 8 videos. We started off with an overview. We've now looked at manipulate the calculation today, factorizing, reordering, partitioning, rounding and adjusting, and loads of doubling strategies. That just means tomorrow we've got multiply and halve, and then finally a little song strategy called jump.
Thank you so much for joining me for this much shorter video on manipulate the calculation. I hope you found it a really useful strategy. It's probably my favourite out of all of the multiplication ones, and it's one that whenever I teach it children, they're always wowed. Wow, that double and halving idea, that's absolutely brilliant. And it's one that you can really develop and really get a lot of benefit out of if you teach it, early enough so the children understand it with the apparatus, and then in later years, maybe years 4, 5 and 6, start to use the strategy as and when appropriate. So thank you very much, and I look forward to seeing you for the next video.
Thank you very much. Hope you found today's lesson useful. I really enjoy that strategy of manipulating the calculation in both addition and multiplication. So I hope you've enjoyed that, and I'll look forward to seeing you tomorrow for probably this is the shortest video I'll ever have done, because it's a very simple strategy of multiplying something and then halving. We're also going to have a quick look at another strategy called jump, which I'm going to show you via one of the Number Fun songs. So thanks very much, and I'll look forward to seeing you all tomorrow.